This is Heliox, where evidence meets empathy. Independent, moderated, timely, deep, gentle, clinical, global, and community conversations about things that matter. Breathe easy, we go deep and lightly surface the big ideas. All right, so I want you to imagine two complete extremes of human navigation.
Right, like polar opposites.
Exactly. I mean, they're separated by thousands of miles, different cultures. One is navigating on water, the other on concrete. And yet they both represent this absolute pinnacle of what the human brain can do when you really push it.
So on one side, you've got someone like Alson Kallen. He's a Marshallese master sailor, an apprentice to one of the very last traditional wave pilots. And he often chooses to navigate the Pacific after the sun goes down.
Which seems totally counterintuitive.
It does, but he says he wants to turn off his vision. He wants to feel the ocean, the up, the down, the sideways movements of every single swell. He says his people navigate, and this is a direct quote, with their stomach.
Wow. Okay, so that's one extreme. And on the other, you have the licensed London taxi driver. To get that license, they have to master the knowledge.
Which is just this chaotic, evolving web of more than 26,000 streets.
They're basically conquering a problem that computer scientists absolutely dread. It's called the curse of dimensionality.
Yeah, the curse of dimensionality is, it's essentially when the number of variables, or in this case streets and turns, grows, the number of possible routes just explodes exponentially.
It's a computational nightmare.
It really is.
So what's the connection here? What links the master sailor who's relying on this pure, subtle feeling of fluid dynamics with the cabbie who is holding a massive cognitive map in their head?
That's the core question of our deep dive today. We're looking at some fascinating new research that focuses specifically on the cognitive mechanics these two groups are using. We've got sources on field research in the Marshall Islands looking at these ancient traditions.
And an academic study that analyzes the incredibly efficient way London cabbies plan their routes.
So our mission is to unpack the secrets of how these expert brains work, from wave patterns that are invisible to you or me to optimizing this huge urban maze.
Let's start with the sea. This is where that sensory mastery really begins.
Okay, so Alson Kallen, who we mentioned, he's the director of an organization called Waan Aelon in Majel, which means Canoes of the Marshall Islands. He's really trying to lead a cultural revival.
His mentor was one of the last known experts.
Captain Joel, yeah. And Kallen's whole goal is to keep this art alive, even using these traditionally built canoes, like one called the Jitdum Kapil.
And the sources really, they really hammer this point home, just how deeply sensory this whole thing is. This isn't about looking at a map.
No, it's the core of the Rometo tradition.
Which means person of the sea.
Exactly. And for thousands of years, these navigators have crossed huge distances just by reading swells. Not local waves, but these massive swells that travel thousands of miles from storms near, say, Antarctica or Alaska.
And when those swells hit the islands, what happens?
Well, the wave energy reflects off them, or it curls around them, and it creates this incredibly complex but predictable interference pattern. The Rometo are literally reading that pattern like a language to know where land is.
It's just tragic to think how close this came to being completely lost.
The sources are pretty clear that the tradition is under an existential threat. A lot of it goes back to the U.S. nuclear testing in the 40s and 50s.
Right, which led to mass displacement.
And most heartbreakingly, in 1954, a hydrogen bomb test just blanketed the ancient waves piloting school on Rongelap with radioactive fallout. It became uninhabitable, a major center of learning, just gone.
That's horrifying.
And that threat, that need for preservation, is what really kicked off the scientific interest. In 2016, a research team went out on a voyage with Kallen.
This was an anthropologist, a physicist.
Yeah, Joseph Gans, John Huth, and an oceanographer, Gerbrand Van Vletter. They wanted to see if they could quantify this ability, measure it.
They were looking at the fluid dynamics, the physics of it all. But they immediately ran up against this central mystery in the lore.
The dilep.
The backbone.
Right, the sort of conceptual wave road that's believed to run between all the islands, all 561 potential paths.
And when they tried to find it with modern equipment, nothing.
Nothing at all. I mean, you can imagine the fear. Was this knowledge that people dedicated their lives to was just imaginary, a metaphor?
But then the sources described this amazing breakthrough from Huth and Van Vletter.
Yes. they realized they were looking for the wrong thing.
Yeah.
The road wasn't a single straight wave they could just measure with a buoy.
It was an effect on the boat itself.
Precisely. They figured out that the dilep is the path you take when you keep your canoe at exactly 90 degrees perpendicular to the strongest swell that's flowing between two islands.
Okay, so when you're perfectly at that 90-degree angle, what happens?
The hull of the canoe rocks symmetrically, side to side, almost perfectly balanced.
Ah, so the dilep isn't the wave, it's the feeling of being perfectly aligned with it.
Exactly. And a crew member on that voyage described the sensation of riding that pattern as feeling like pidoto.
Which means?
It means diarrhea.
Tickles.
It sounds crude, but that's the genius of it. It's visceral. It's an unmistakable physical cue. Your body, your gut, tells you you are on the path. It proved the knowledge was physical, not just abstract.
That's a critical distinction, and that proof then led to the more recent research.
Right. So a second project started in 2025, this time way more focused on the cognitive side. They brought in neuroscientists, Hugo Spires, Maria Ahmad, and even a philosopher.
And this time, they have brain recording gear, accelerometers, eye trackers. They weren't just measuring the waves, they were trying to measure the internal process. How does the brain actually build this map from a gut feeling?
They'd have the sailors draw their location and the wave direction every half hour, trying to see how that spatial awareness is built and maintained out on the open sea.
And the implications here are huge because it connects this ancient skill to very modern neurology.
Absolutely. The research makes an explicit link to neurological diseases. Disorientation is one of the very first symptoms of Alzheimer's.
And Alzheimer's is associated with the shrinking, the atrophy of the hippocampus, the brain center for spatial memory.
And since the Pacific Islands, including the Marshall Islands, have a high incidence of Alzheimer's, well, if you can understand how these expert navigators use that part of the brain so effectively, you might find new ways to diagnose or even train against cognitive decline.
Wow. So preserving ancient knowledge could literally help protect modern minds.
It's a profound idea. And
Yeah.
that ability, the brain's power to create and use these complex maps, is what connects us to our second group of experts.
So we're transitioning from the open ocean, where the map is built from feeling.
The urban jungle of London, where the map is built from, well, from brute force knowledge and experience.
This feels like the perfect other side of the coin. The taxi driver study gives us this controlled, real-world example of beating that curse of dimensionality we talked about.
And the bar is just ridiculously high. Passing the knowledge means you have to internalize this spider web of 26,000 streets. And we already knew from older studies that this has physical consequences.
Right. This is that famous finding. Their hippocampus, that spatial memory region, actually gets physically larger.
It's a stunning example of neuroplasticity in adults. For most of us, our sense of direction gets worse over time. For them, that part of the brain gets bigger and better the more they use it.
So this new study with 43 drivers, it went deeper. It wasn't about anatomy, it was about strategy.
Yes. They gave them 315 complex routes. They had to mentally plan it and then verbally call out the route street by street, just like they would for a passenger.
And they tracked two key times. First, the silent planning time before they said anything. That's called offline thinking time, or OFFTOT.
And second, the call-out time, or COT, which is the time between naming each street on the route.
And this is where it gets really good. The data showed a really strong negative correlation.
Meaning the longer a driver spent thinking silently at the beginning,
the shorter their total time was for the verbal call-out phase.
Now, hold on. If you spend, say, a minute planning silently, aren't you just kind of doing the route twice? You'd think that would only help with the first few turns.
That's what a novice would do, right? It's a sequential turn-by-turn plan.
Exactly. But the study found that a longer silent planning time didn't just reduce the time for the first few streets. It reduced the call-out time equally across the entire route, from beginning to end.
Which proves the initial planning was global. It wasn't local.
Yes. The driver isn't just figuring out the first three turns. They are solving the whole puzzle in their head, all at once.
And that has to be the shortcut around that curse of dimensionality, because the sources say that trying to plan a 30-street path with a simple tree search could mean evaluating over 1 billion possible sequences.
The human brain doesn't do that. It doesn't brute force the problem. It uses rational shortcuts. And the researchers modeled the driver's strategy using two key metrics for planning complexity.
Okay, let's break these down because this is the secret sauce. The first one is successor representation, or SR.
SR is basically a measure of how common a particular street is. Is it a major artery you'd use all the time to cross town, or is it some obscure dead end? It's about familiarity and usefulness.
Okay, SR is how common it is. The second one is local transition entropy, or LTE.
LTE measures the complexity of the decision you have to make at a certain point, usually a junction. How many possible turns are there? How confusing is it?
So a simple four-way stop is low LTE.
Very low. But a massive 6-exit roundabout in rush hour is extremely high LTE.
So the magic is in how they combine those two ideas. The expert driver doesn't waste time on easy turns.
No, it's a rational strategy. Their brain jumps ahead to prioritize the junctions that are both common high SR and difficult high LTE. That's where you get the biggest bang for your cognitive buck.
They called it non-sequential decision pre-caching.
Non-sequential decision pre-caching. They're mentally jumping forward in the route, solving the hardest problems first, and then storing those solutions to retrieve instantly when they're calling out the route.
That's why their time between streets, the COT, is so fast, even at the tricky parts.
The paper gives a perfect example. The junction at Shaftesbury Avenue, a major complex turning point in central London. The difficulty of that junction, its high LTE, was in the 95th percentile for complexity in the whole study. And the data shows it was clearly one of the points being solved during that silent offline planning phase.
So whether you're Alson Kallen feeling for that perfect 90-degree alignment to a swell, or a cabbie mentally solving the Shaftesbury Avenue junction before you've even left the curb,
The principle is the same.
both are using these highly refined internal models of their environment to prioritize and solve the hardest parts first. It's not about simple sequential thinking.
Not at all. It's about perceiving or calculating the most challenging part of the problem and tackling that right away.
Which brings us back to the broader science of the brain's inner GPS.
Right. We've known about the basic parts for a while. John O'Keefe discovered place cells back in the 70s. They fire when you're in a specific location. They tell you where you are.
And then in 2005, the Mosers discovered grid cells.
Grid cells are different. They fire in this incredible hexagonal grid pattern as you move. They help the brain calculate distance and direction. They tell you how far you've gone and which way you're facing.
And together, those cells create our internal navigation system. Which brings us to the really stark takeaway for anyone listening who, probably uses a GPS app every single day.
Yeah, the finding here is a little alarming. Following step-by-step instructions from an app, it just does not activate the hippocampus in the same way.
So you're outsourcing the work.
You are, and studies show that people who rely only on turn-by-turn GPS draw less accurate maps from memory and remember fewer landmarks. You're not building or maintaining that skill.
The sources say the real danger of GPS is that we never do not know exactly where we are. It takes away the chance to get a little lost, to make a mistake, to learn from it.
And if you never use your hippocampus to actively solve a route, it's a muscle. It might atrophy.
Our ability to navigate is so fundamental, it's tied to memory, planning, decision-making.
There's even a strong hypothesis that our ability to time travel mentally, to plan for the future, to remember the past, that it evolved directly from our ability to travel in the physical world.
So if we outsource the physical navigation, what does that do to our mental navigation?
It's a big question.
So what we're seeing is that true mastery on water or on pavement isn't about just following steps. It's about using deep knowledge to literally change the structure and the strategy of your brain.
The cabbie is planning the fastest route by jumping ahead to solve the problem intersections first. The wave pilot is physically aligning his boat to that one single point of stability, the dilep, that lets him ignore all the other chaotic noise of the ocean.
So we'll leave you with a final thought on this. The ancient Marshallese technique and the modern cognitive science of London's streets. They're both pointing to the same truth.
The most efficient way through a complex problem isn't always a straight line. It's about prioritizing and solving the most critical junctions, the most complex curves, first.
So in your own life, maybe in learning something new or a project at work or even a relationship, what are the high complexity, high value junctions that you need to mentally pre-cache and solve before you even start the journey?
Don't just follow the sequential steps. Think like a cabbie. Find those critical pivot points first. Thanks for listening today. 4 recurring narratives underlie every episode: boundary dissolution, adaptive complexity, embodied knowledge, and quantum-like uncertainty. These aren't just philosophical musings, but frameworks for understanding our modern world. We hope you continue exploring our other podcasts, responding to the content, and checking out our related articles at helioxpodcast.substack.com.